present civilization rests upon a solid foundation of steel, friendly as the sun, stronger than stone, and more pliable than clay. Man discovered how to make iron before he could write, but only in the past century has he learned to make it so well, so abundantly, and so efficiently. Out in the sea, off the coast of Kyushu, Japan, the Yawata Iron and Steel Company will build a steel plant. Japan has no land to spare, so she must reclaim it from the ocean. Dredging buckets dig down to 43 feet in Tobata Harbor. Barges carry the mud to the reclamation area. Jaws open to dump the load. Upon this sea waste will rise new wealth, the new Tobata Steelworks. Suction dredges stick their burrowing booms underwater. Each of them has a 1,000 horsepower engine to pump water and mud. Long pipes gush it into the reclamation area. 3,000 square yards of new land every day. The deep-sea ships that will sail to the steel plant will require a tremendous dock. Pilings go down to build it. This work has its dangers and its disciplines. Each flat piling must be set properly before it can be driven down to bedrock to form individual cells. A slight error of placement can spoil the whole circle. One cell at a time. Connecting arcs will join them all, and earth will fill the line. Pile drivers begin their work, pounding steel down to the bed of the sea. Additional steel pipe columns are set inside the cells and driven down into bedrock too. These will support the massive unloading machines. Foundation work begins for a blast furnace, the heart of the steel plant. The segments of a round iron shoe go down into place. Ground has been dug in a circle. The iron shoe awaits a concrete well to form the base for the furnace. The iron shoe, 53 feet wide, will sink to the bedrock with the concrete wall on top of it. Clam buckets dig away the earth in the center. This forces the well to drop under its own weight. The sinking rate progresses almost imperceptibly, 10 inches every 24 hours. With scrupulous care, the diggers keep the well horizontal to ensure perpendicular sinking. As digging continues, the iron shoe bites into the earth. As the well sinks, new walls are added. By now, the well has sunk more than 40 feet, and 65 days after it started, it reaches bedrock. Concrete fills the bottom of the well, and earth goes on top of it to form a solid well foundation. Finally, the top is covered with a thick concrete layer, and the blast furnace will tower 250 feet above it. Beyond the blast furnace, another foundation has been finished. The main line of the hot rolling mill stretches 1,200 feet, as straight as man's eyes and precision instruments can make it. Day after day, the tunnel and highway leading to the Tobata steel plant rumbles with traffic. The project demands hundreds of trucks, thousands of machines, millions of parts. Other supplies are unloaded from ships at the completed portion of the dock. Above the dock, construction of the ore unloader, the largest in Japan. Drilling, processing, and machining. Every piece of steel for the furnaces and factories has a number. The converter plant steel frame rises more than 145 feet. A huge boiler and dust collector will be installed on top of it. The riveters work like well-trained athletes. Steeplejacks set another tempo, removing molds from a newly constructed chimney, higher and higher, and back and forth. Dominating the 2,000 acres of reclaimed land, the steel frame and steel shell of the great blast furnace has risen too. High and straight it towers. A steel mantle will cover the top of the blast furnace shell. Up it comes, 140 feet above the ground. At last, the builders fit it into position. Next, the hopper goes to the top. This apparatus will mix the furnace charge of ore, coke, and fusing stone. Thousands of workmen rivet, hold, guide, and hammer to build the furnace up and up. Everything about the blast furnace must be able to stand great strains of weight and pressure and heat. Within the outer steel shell, a fire brick lining must be laid. The lifespan of a furnace depends upon how well the bricklayers do their job. Copper cooling boxes are installed among the bricks. Water will flow through them to protect the furnace walls from high temperatures. Black carbon bricks, ultra hard, heavy, and strong, are lowered to the furnace floor. Only blocks like these can withstand the constant heat of molten iron over 3,400 degrees Fahrenheit. To prevent distortion, they are placed as carefully as if they were diamonds. Furnace interiors used to last through only 4 years of continuous service. This one should last twice that long, thanks to its splendid lining. Outside, the huge collection pipes for conducting gases from the blast furnace must now be set in place. Their weight, their size, and the height at which they must be installed make this job perilous. 250 feet above the ground, the pipes are inched into position. It takes 4 hours simply to lift and place the pipe sections, and 10 more hours to install them. As the blast furnace nears completion, so do other structures. The converter shells have been finished and placed. These will convert raw molten iron into steel, 60-ton portions at a time. In the control room, a technician checks the oxygen valves and tilting controls. The Tobata steel plant will be second to none in the efficiency of its operations. Once this was the open sea. Now it is a great storage dock for coal, ore, and limestone. Japan must import nearly all of her requirements for steel. High coking coal comes from the United States and Australia. The 16,000-ton ore carrier Nita Maru brings raw materials from Malaya, India, and the Philippines. The unloader buckets take 20 tons of ore at a bite. Coke must be made from coal and stockpiled before the blast furnace can begin operations. "48 coke ovens will supply Tobata's furnace. A day of baking completes the process. Flaming coke falls into the open, quenching cars. One by one, other fires are ignited. Storage pits for ingots, to equalize the heat inside of them, are lit for the first time. The whole plant awaits testing. The motors of the great slabbing mill are turning. The rollers that reduce the huge steel ingots into flat slabs and strips exert their tremendous pressures. A half-dozen giant rolling mills make up Tobata. Their motor rooms, machinery, and master switches all must be tried out. The mills require enormous amounts of power. The engines that turn the rollers in this mill have a combined output of 25,000 horsepower. Acceleration tests. Last touches are added to the blast furnace. 30 stories high, welded. Before the inaugural firing of the blast furnace, bricks are laid for the runner. This trough will guide the molten iron when it runs from the tap hole to the ladle. Now to prepare the fire. Wooden ties must be placed at the bottom of the furnace. Waste heat caused by drying bricks makes this job a sweltering task. The men work in 30-minute shifts. The ties are piled in more than 20 latticed layers, whose meshes grow finer as they rise. Firewood is piled in the shape of a funnel to receive the coke, ore, and limestone, kindling for a monstrous bulkhead. Next day, the blast furnace is charged with raw materials: coke, iron ore, and limestone, mixed carefully and in exact amounts make up the recipe. Cooks keep careful track of what, where, and how much goes in. At last, the time has come to light the furnace, and a solemn Shinto ritual marks this great occasion. The priest strikes steel and flint for a spark to light a paper spill. Then a splinter is set afire and placed in a brazier filled with charcoal. Workmen take individual scoops of the hot coals to the furnace's air blast openings. Mr. Ojima, Iwata's president, symbolically ignites the interior. In central control room, a switch is turned, and a hot air blast slams into the furnace. The ties have started to burn, and ignited gas escapes from the bottom. The blast furnace at Tobata is in operation. It will burn without a stop for years to come. Heat conditions within the furnace are recorded from moment to moment. Flames at the tap hole are forced down with mud. Through the night, smelting of iron goes on inside the blast furnace. Next day, 27 hours after the firing, the moment for the first tapping approaches. Ladle cars arrive in the midst of a heavy rain. At 2 p.m., the hour scheduled for tapping, company officials and personnel watch with keen interest. The task of opening the tap for the first time is not easy. 10 minutes pass, and then another 10 minutes. At 2:30, the tap hole is finally opened, and the molten iron flows down the runner. First tapping fills 4 ladles, totaling about 150 tons. The 60-ton converter eliminates the impurities of the raw iron. Violent combustion as iron becomes steel. Red-hot ingots roll into the mill. The giant machines roll them, squeeze them, turn them. Roller after roller helps to make the slabs longer and thinner. Finally, the long steel sheets are cooled and wound into steaming coils. Modern steel can be shaped into myriad forms and sizes, for as many uses as man can devise. But one of the most important single classifications is steel in the form of sheets and strips. From this, it can be fashioned at other factories for automobiles and appliances, for thousands of different uses. 3 years after its construction began, the Tobata plant of the Iwata Iron and Steel Company operates continuously, from the handling of raw materials to the smelting and rolling of finished steel. Its storage facilities now handle hundreds of thousands of tons of materials. The volume of its steel manufacture and the quality of its products have helped raise Japan to be one of the leading steel producers of the world. Japanese production aims call for an output of 48 million tons by 1970. Her steel industry is exerting every effort to expand and improve its production facilities. This single furnace now produces 1,500 tons a day. Steel, the most useful, the most needed metal of mankind. But Tobata is only a beginning. To meet the growing demand for her steel, the industry in Japan must continue to grow. Where land does not exist, the Japanese people will create it. The miracle of Japan's newest steelworks lies in her people's imagination and will to remodel nature in their desire to create new wealth. In this case, new wealth upon the wastes of the sea.